Y'all was talking about this girl named Bree, making it mad, making it sad, boy. Y'all was talking about this girl named Bree, making it mad, making it sad, boy.
Things are getting complicated. Nothing's gonna stop this shit from sinking down. Think we need some mediation. I get it all for you. Why the hell do I fall for you? Baby, 12 a.m. you're dodging all my phone calls, baby. Why ask me? You already know it all, baby. Don't you play around with me tonight? If we go in, baby, don't do it tonight. If we go in, baby. Don't do it tonight. Don't do it tonight.
still.
I'm here breaking my neck, looking over my shoulder. Stepped into your skin, got me tripping over myself. Figured I would say something, passing the time. If you come on over here, we could be on the same side.
Same side, 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 same side.
I'm here breaking my neck,
Y'all was talking about this girl named Bree. Making me mad, making me sad, boy. Y'all was talking about this girl named Bree. Making me mad, making me sad, boy. Y'all was talking about this girl named Bree. Making me mad, making me sad, boy. Y'all was talking about this girl named Bree. Making me mad, making me sad, boy. Y'all was talking about this girl named Bree. Making me mad, making me sad, boy. Y'all was talking about this girl named Bree. Making me mad, making me sad, boy.
is gonna stop this shit from sinking down. Think we need some mediation. I get it all for you. Why the hell do I fall for you? Baby, 12 a.m. you're dodging all my phone calls, baby. Why ask me? You already know it all, baby. Don't you play around with me tonight? If we go in, baby, don't do it tonight. If we go in, baby.
still.
I'm here breaking my neck, looking over my shoulder. Stepped into your skin, got me tripping over myself. Figured I would say something, passing the time. If you come on over here, we could be on the same side.
Same side, 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 same side.
Y'all was talking about this girl named Bree, making him mad, making him sad, boy. Y'all was talking about this girl named Bree, making him mad, making him sad, boy. Y'all was talking about this girl named Bree, making him mad, making him sad, boy. Y'all was talking about this girl named Bree, making him mad, making him sad, boy. Y'all was talking about this girl named Bree, making him mad, making him sad, boy. Y'all was talking about this girl named Bree, making him mad, making him sad, boy.
Things are getting complicated. Nothing's gonna stop this shit from sinking down. Think we need some mediation. I get it all for you. Why the hell do I fall for you? Baby, 12 a.m. you're dodging all my phone calls, baby. Why ask me? You already know it all, baby. Don't you play around with me tonight. If we go in it, baby, don't do it tonight. If we go in it, baby, don't do it tonight.
shoulder. Stepped into your skin, got me tripping over myself. Figured I would say something, passing the time. If you come on over here, we could be on the same side.
Same side, same side. Same side, same side. Same side, same side. Same side, same side.
I'm here, breaking my neck, looking over my shoulder. Stepped into your skin, got me tripping over myself. Figured I would say something, passing the time. If you come on over here, we could be on the same side. 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 On the same side.
Same side,
On the same side.
same side,
On the same side.
same side,
On the same side.
same side.
On the same side. On the same side. On the same side. On the same side.
everybody, and welcome to GraphQL Asia 2021. I am super stoked to introduce and welcome everybody to the conference. A few things I'd love to mention to you right now. First, our sponsors, Hasura. Hasura, the instant GraphQL API for your database. Yugabyte, Postgres, or the just released SQL Server support. Boost your developer speed with Hasura. Right now, you can also get 1 month for free if you use the code here, GraphQL Asia, and navigate over to cloud.hasura.io. Then we've got StackHawk. So be sure to go check out the sponsor booth. They've got a crew in there hanging out that would love to talk to you. They are an application security scanner built on Zap. They can help you manage your security and testing within your build pipelines, etc. Then we have Yugabyte. Thank you to Yugabyte. It is a geo-distributed high-performance web-scale database. So check them out when you want to really scale your database back in. Head over to that sponsor room, and they also have things that they'd love to talk to you about. So go have a chit-chat with them. And then Atlassian, you're all probably familiar with them. They are the producers of Jira, Confluence, Bitbucket, Trello, Bamboo, and so many more software packages and services. So they're also in a sponsor room. Have a chat, let them know what you're up to. I'm sure they have all sorts of things they'd love to talk to you about. And also they, like many, are hiring right now. We also have many community partners that have been helping us out, getting the word out and talking to all of you out there in the community. A huge shout out to all of them. React Bangalore, Women Who Code, and so many more. React JS Philippines, GraphQL Bangkok, GraphQL Copenhagen, GraphQL Sydney, etc. So if you're part of those communities specifically, thank you. And if you're part of the overall community, thank you very much for joining us today. This is going to be a great time with a lot of very useful information and talks. And then we also have, as I was saying a little earlier, jobs. So check out www.graphqlasia/jobs to learn more about the jobs at many of our sponsors and others that they're looking to fill. And with that, I want to introduce to you Tanmay. He is the CEO and co-founder of Hasura, often referred to as a Stack Overflow of powered full stack developer experience, and has a wide gamut of ideas and interests that span from React, GraphQL, Node.js, Haskell, Docker, Postgres, and Kubernetes, just to name a few. He's passionate about making the complex things simple and is one of the instructors at India's largest MOOC, Imad.Tech, with over 250,000 students. And with that, I'll let Tanmay take it away.
Thank you, Adrian, for that introduction. And super happy to be here and kick the third edition of GraphQL Asia off. I am going to be talking a little bit about GraphQL and developer productivity via data-oriented architecture. So this is a topic that I think is a little bit future facing, and it's going to be very interesting to kind of share some of these ideas and the way things are evolving with everybody here. And then of course I'll have some time towards the end, so would love to take some questions from you folks as well, time permitting. But that said, let us dive in. So when we, I hope you can see my slides. All right. So before I start things off, a quick introduction. I'm Tanmay. I'm the CEO, co-founder at Hasura. I before starting Hasura, I had done a whole bunch of things, and it's interesting because that kind of given me a fairly interesting perspective when I kind of approach this topic of developer productivity, and we start talking about kind of the way architectures are evolving, right? Just to give you a sense of the kinds of stuff that I've been up to, is I built my own full stack framework. I did it with Django and jQuery based SPA framework. And many years ago, before when SPAs were just becoming a thing, which was a framework by Twitter. I actually happened to meet the creator of Flight one day in San Francisco, and he was like, "Ah, you're the first user that I've met in person." And I was like, "Yes, I was probably one of the few users there." And this was actually a framework based off of jQuery before React and stuff were popular. And then, of course, you early users of compared to Redux, and then kind of other ways of state handling that have emerged since then. I also built when we built kind of our own data access engine before Hasura. The API that we used was very similar to GraphQL. It was like GraphQL in JSON, and that was also a very interesting exercise. And then, as a part of the kind of the previous company that I used to run, the work that we used to do along with the team, we built several types of different tools, everything from kind of database orchestrators, API gateways, CI/CD tooling, and whatnot, right? And the reason I mentioned this is because as we kind of talk about evolving architectures, I was a big fan of reinventing as many different things as I possibly could get my hands on, right? And it was an interesting exercise because it was fun to do, and it was fun to use that to learn and to try them out with companies large and small, some of the largest companies in the world, with some of the with some people who are just getting started, right? And then, of course, one of the things that I did that I really enjoyed that still kind of lends me perspective today is a massively open online course that I ran called Introduction to Modern Application Development, which became one of the largest MOOCs in the world at the time, and that was also very interesting because there's this kind of this gap that people have in being able to consume ways of doing modern development and actually kind of building with it, right? And trying to understand what that gap is and what kinds of problems people face, right? And so it's been a fairly interesting journey when we think about this overall idea of, what are the kinds of things that we need to do to make ourselves productive, and what are kind of the key bottlenecks, right? And what are those challenges like? So that's just to set some context about kind of where I'm coming from, right? With that, let me dive in straight into GraphQL. So when we think about, and this is, I've said this before, but I used to be a GraphQL skeptic, right? And it took me some time to fall in love with GraphQL, and even now, 3 years in to our journey with GraphQL, maybe 5 to 6 years in with the journey for everybody in the world with GraphQL, right? It's very interesting to kind of talk about why people like GraphQL, right? When GraphQL was kind of born, right? It was kind of born out of two important problems that needed to be solved and when this happened at Facebook, there were two fairly kind of important problems that they were running into, and and GraphQL was kind of born as a specification out of that, right? One of the first big problems was that if you have a UI and this UI needs a lot of pieces of data, right, to render itself, composing all of that data and effectively making a single API call required a tremendous amount of manual work, right? As a developer, I would have to go in and say, okay, this component, I make this API call, but then I know that it's kind of overlapping with this piece here. So let me fetch it in a way that I can share some data, right? And then we realize that wait, but both of these elements are part of a larger element. So maybe I can just make a larger API call, get the full JSON object, right? Stuff that we all know about very well, right? And when we think about the tremendous amount of manual effort that was involved in kind of in putting this together, people wanted, and there was this need for saying that to make developers more productive, we're going to need some kind of automation here to help compose this together. The second piece, and so the things, the effects that you see in GraphQL today of that kind of composition stuff is GraphQL fragments and the relay specification for GraphQL, right? And these are two things that we actually don't use that often with GraphQL, right? Most people who are using GraphQL, if you ask them, hey, are you using GraphQL fragments? They're like, are you using the relay style specification of GraphQL? And they're like, maybe, but they're few and far between. Now, that's not to say I don't love both of these aspects. I do, and I in fact talked about this last year, which was a journey for me to kind of fall in love with the relay style of GraphQL, which is very different and is extremely interesting. And once you understand that, you're like, why? How can we build UIs in any other way? It doesn't make any sense, right? But it's still a little bit. It's a little bit harder to get used to as a specification, but it's a very powerful specification because it solves that problem of being able to kind of compose a UI very well, right? And then the second problem is, type safe JSON interaction, right? Which is JSON is an untyped API. You have clients and servers talking to each other. There has to be some type safety. Otherwise, how do you enforce that type safety if it's not going to happen? With JSON, everybody will have to do it in application code. Humans will have to do it themselves and take care of it, right? There'll be just a lot of unnecessary repetitive code that people are writing to validate the JSON that they're sending and the JSON that they're receiving, right? Now, when we think about these two reasons, right, they're massively important reasons. But if you think about why GraphQL is popular today amongst all of us, if you were all sitting in, for example, a conference hall, and you looked at your neighbor and you asked them, hey, so why do you love GraphQL? Chances are that they'll kind of say something similar, right? And we'll all say something kind of similar to these reasons behind kind of the birth of GraphQL. But honestly, the biggest reason, right, why people really like GraphQL today, from what I've seen, and one of the most common reasons, is that it is quite probably the best way today of being able to explore and try and integrate a new API, right? There just isn't anything better, right? If you've manually had to look at like hundreds of API endpoints and you've tried to use them and tried to kind of figure out what API call does what, read pages of documentation is outdated, somebody else comes in and has to update that documentation, you have to verify it with another human being, then you try it out, right? There's a whole thing around it that's very painful when you're consuming APIs. And then when you suddenly first kind of look at GraphQL, it kind of blows your mind. You're like, yes, this is what I've wanted from APIs all along, right? Obviously, all of my data is interconnected. I want to go in and fetch all of that information when I want it. I want to query for it exactly the way I want, right? And so and the ability to kind of explore that API incrementally, right? Just by kind of auto completing And then if you look at tools that have kind of gotten created since then, like Graphical Explorer and whatnot, they really help this, right? So it's a slightly different use case, right? From this use case of saying that it's specifically a thing that makes automatic composition easier, right? Or it's specifically only for type safety. It goes kind of beyond both of those two for a good reason, right? And that reason is that when we think about what we really want from an API, right? What we really kind of want when we want things like GraphQL, um, there are two things, right? The first is that we want self-serve APIs. So what that means is that we want this ability to not have to wait on somebody else to get the API that I want, right? I don't want to wait on another team, another human, or on another process for any part of the API lifecycle. I don't, when I'm browsing APIs, I'm exploring it, I'm trying it, I'm integrating it, right? Any of this, I don't want anybody else involved because I just want to go in and do it myself, right? And this is the story of development world over, right? It's the story of a developer. The developer's like, I need to get some stuff done. I will go and figure out how to get stuff done myself, and I will do it, right? I will use these libraries, I'll use these services, I'll use a particular framework, I'll do whatever, and I can get stuff done, right? And that individual is massively empowered when that individual is allowed to kind of get productive by not being blocked on other things and other people, right? And that is kind of this massive underlying need that has made GraphQL extremely popular, which is saying that, hey, if you want a particular way of querying the data, or you want a particular way of, or you want to browse the API, you don't have to wait for anybody. You don't have to wait for the best handwritten documentation. You don't have to wait for anybody to send you any material. You skip a large part of the API onboarding that you would typically have to do, right? You'd have to have a conversation between people talking about, hey, this is what our APIs are like, and somebody else is like, yes, this is interesting. Nice for me to see what this API is like. I can start integrating it, right? This whole process just goes away. It's self-serve, right? The second big thing about GraphQL is that you can query what you want and whenever you want it, right? That means that, again, without having to be blocked on anybody else, when I need to query for a certain slice of data, I can query that slice of the API, right, on demand, and I can fetch exactly what I want. Now, this again, there are multiple kind of reasons here, right? Like there's a performance and a network impact here, which was a big part of the kind of GraphQL Genesis story, which was to say, hey, we have to kind of make our network transfer more efficient because every byte matters, especially at the scale that Facebook was at. And so being able to kind of make those payloads efficient was really important. But when we think about, but even as humans, right? In data models and API models are becoming massive, right? Like a person probably has 100 fields and then a million interconnected things, right? So if I want to keep my sanity while browsing an API, I want to fetch the fewest number of things possible, so that my cognitive overload is low, right? And I'm just fetching those few things. I don't actually want to fetch one JSON object that contains 100 fields and then some nested objects and lists and this and that, because I'll go crazy, right? And this ability to kind of query what we want and whenever we want it is really huge, and it's super important, right? And I think that these two kind of underlying reasons, right, behind the popularity of GraphQL, but also everything else, right? Also a lot of other tools that we use, is important to take kind of cognizance of, right? Because they have a massive impact on developer productivity, beyond kind of just the technical features of GraphQL, right? There's a certain kind of human and organizational power here that we're talking about, which is to productivity, right? Which is beyond just a technical benefit. And then if you take a step back, right? It kind of sounds like the database story, but for APIs, right? This idea of saying that it's self-serve and you can query for what you want, right? It's it's like the database story brought forward, right? And just to give you an example, and I'm sure most of us have worked with databases. Imagine the world before a database, right? There were only files, and then you wanted to get data, you had to fetch each file, right? And maybe the data was split across files. Maybe once you fetch the files, you had to process them. That's ridiculous, right? Like you're just getting pieces of data. It makes, I mean, it makes you would start like getting very angry with the work that you're doing and with people if that's how you have to interact with data, right? And then when SQL came along, and believe it or not, one of the most killer developer tools of its time was actually Oracle. Um, and when SQL and databases came out, people just right, they were like, "What? I don't need expertise of like how to work with a file system and a disk to be able to fetch this data, right? I can just ask for it in this slight like human readable language, and I can just fetch whatever information I want. That's insane, right? And I don't need documentation telling me what file is what, and how things are laid out and what the structure is, and I can just kind of look at different tables and join across them and fetch the right records and filter by things and filter only the right columns, right? That was mind blowing. And GraphQL is very similar to kind of that journey, right? And that leap that we had in developer productivity, but for APIs, right? And when we think about what APIs are essentially a way for us to, I mean, there are lots of different ways to talk about it, but in this particular case, in the way I'd like to introduce it is that APIs will help us kind of interact programmatically with a particular domain, right? And a domain is a collection of data and logic, right? So each domain has data and logic that domain understands really well. That domain is represented by the data and logic, right? And these domains, especially if you're in an organization and you have multiple teams, these domains are owned and operated by different teams, right? And so people expose APIs, and then maybe different teams talk to each other via APIs when they're building services or products, or maybe there's a consumer that is talking to multiple different domains and connecting that data, or connecting the kind of methods there, and using an API for doing that, right? And again, this is not particularly new. This has been around for a long time. I'm going to be using that kind of image quite frequently in the slide to represent a domain, which is a data plus logic. This is one of my better architecture diagrams. In this context, right, of when we think about kind of like APIs and APIs for domains, and we kind of think about GraphQL. A GraphQL layer allows us to kind of bring together the data and logic that is siloed in different domains, right? And that's very interesting, right? That's massive for a lot of us, because we're not just talking about the API productivity of a particular domain. We're talking about the API productivity across domains, right? Which is awesome. And the way I think about this is that when you think about data and logic for each domain, right? And you have everyone's data and everyone's logic that's kind of split across, right? The data is kind of interconnected, or may not be interconnected, but usually has some connections, right? It's not like it's a graph of one form or another, right? And then when you're kind of invoking logic of a particular domain, what that logic is doing in that domain, right, is that it's modifying that data, right? And it's returning references to the modified data. That's what each piece of logic does, right? Modifies data, modifies state, and returns references to the modified piece of state, right? And so this is kind of what each domain is, and we want to kind of bring all of this. We kind of want to bring all of this information together, right? And this is kind of where we want to think about GraphQL, right? And it's a little bit confusing because this story doesn't necessarily work very well with GraphQL, because GraphQL is this kind of monolithic layer, and we're talking about different services, right? It doesn't fit into this kind of service-oriented architecture picture as naturally as we would want it to, right? And so because it's a little bit different from the way that we think about our APIs, right? And so one of the terms that I heard from, that I first came across from Adam in last year's Enterprise GraphQL conference was this notion of data-oriented architecture, which is a slightly easier way to kind of reorient yourself and think about GraphQL across services. And it's to say that, hey, why don't we shift towards a data-oriented architecture instead of a service-oriented architecture, right? And in this particular in the talk that I'm referencing, which you should definitely go and watch by Adam. All right. I apologize, my animations are playing it. All right. So when they had this is literally the image that I've taken from Adam's slides, which is these are the kind of different services, and they're all interconnected and they're all calling each other, right? So this is kind of the RPC way of doing things, right? Where each service can make arbitrary RPCs or API calls to other services and invoke procedures, invoke logic, and logic returns data. You're invoking procedures and procedures return information, right? That's the model. And that model things, especially when you have an explosion of services, get a little bit messy. We're also now living in a context, right, where for a lot of developers, we might not even have a service. We might just have serverless functions that are running, right? And so you have different functions just running all over the place. And then like, wait, what happens now, right? Like, do all of these functions call each other? This is worse than spaghetti code with go-to functions that we used to write back in the day. Well, actually never, right? But we heard about writing back in the day, right? So that, and that was a problem, right? And so when they start thinking about kind of how they would unifying this, right? And they thought about using GraphQL, they said, let's think in terms of data. Let's say that each service, instead of exposing procedures, is actually exposing data, right? And it's finished data. It's data with logic, right? And so you're exposing that data. There's stuff that's happened to that data when you're exposing it. And there is this idea of saying that, okay, cool. You know what? We can kind of bring in data from these different places, and this data is interconnected, and something in the middle has to figure out how this data is kind of being pieced together. And that's kind of where their GraphQL infrastructure, which they've named Viaduct, starts fitting in, right? Is to say is that let's thinking in terms of data is easier. I mean, maybe at the end of the day, it'll be the still same kind of number of spaghetti calls, but as a human, you won't see that happen, right? As a human, you'll see a nice kind of interconnected data, this cognitive graph of how your models are laid out, and then you can go query that, right? Very similar was a talk by the LinkedIn folks a few years ago, talking about kind of their internal data layer that they were building, which was also using GraphQL. And if you look at the diagram that I have on the right, which again I've taken from Gopal's slides, and again you should definitely watch that. Is if you look at in the middle, right, you have these different domains, right? And if you look at like the top,
All right. Thanks a lot to Tanmay there. He's rejoined us, even though it seemed like there was a quick freeze. All right, back to Tanmay.
But yeah, so and so this was kind of a very similar problem that the folks at LinkedIn were running into, which is that they also kind of wanted to solve a lot of these common problems with being able to deal with data and data of different types, data everywhere, data across domains, and they need a way of doing it, right? And they talk about kind of their emerging GraphQL architecture in that context, right? When the way that the kind of need for this, right, is developer productivity and making sure that things are kind of making sense when you have that explosion of the amount of data that you're going to have. You start off, even if you start off today with data in one place, it's almost instantly going to be data in like 5 different places, right? Maybe some are in different services in your own organization. Maybe something is in a SaaS service, right? It's kind of all over. When we think about kind of the architecture, the mental model that we've had, right, so far, we think about this kind of a model, this kind of picture that I've put together on the side here, where you have different domains expose services, everybody runs an app server, then you kind of put that together and you have maybe an API gateway if you want to unify access across it, right? We're not talking about kind of the internal service to service interaction. That is still RPC type, right? Which is a little bit of what I was talking about before. But in this picture, right, when you think about the different types of problems to be solved, you think about logic, authorization, caching, security, unified API, the fact that your API gateway is a single point of failure. So it needs, there's a lot of kind of non-functional work that goes into that API gateway to prevent it from being a single point of failure, right? So that's redundant, it's highly available, it can handle failovers of upstream services, all of that kind of stuff. But all of this work has to happen across the app server to the API gateway layer, right? And this is a little bit, this is not fun because you're not sometimes sure where should I be putting this caching logic. I need to put it in the app server, should I put it in the API gateway? It kind of makes sense in both places. Who they better at doing it? Why should I do it in one place or the other? And at the end of the day, it's a repetitive problem that we're solving. Is everybody solving the same problem? Why don't we just do it in a central place? And there's like questions like that that often come to mind, right? In this kind of a data-oriented way of thinking about things, right? You think of each domain as data plus logic, right? And then you think of your GraphQL infrastructure as being slightly thicker than just a facade. And with this kind of mental model, you're saying that, hey, we're going to connect these different domains, right? And each domain is data plus logic. That's it. And we try to pause that as much as possible. And all of the other stuff, especially stuff that's non-functional, but maybe also absorbing some of those other concerns, right? Like let's say caching or authorization, they can start going into your GraphQL infrastructure, right? And this becomes an interesting, this becomes kind of a slightly different way of thinking about things, right? At Hasura, we just announced Hasura 2.0 yesterday, which is a big deal for us. But we're thinking deeply about problems like this that will help with developer productivity. I'm going to not talk about this too much in the interest of time as well, but there's several interesting kind of areas that we're working on in that kind of same space of doing things in the way that this architecture is evolving, right? There are fairly real challenges ahead of us when we think about this kind of architecture in as a community, right? The first is that in the long term, when we think about simplifying things, we want layers to collapse. We want fewer number of things to do, not a larger number of things to do. For example, when you use the cloud today, think about the amount of technology that's collapsed, and you click on a button, you get a VM, right? It's just, that makes people productive, right? You explode the number of layers, that's a short-term kind of thing. It's not necessarily making you productive, right? There are challenges here when we're thinking about the traditional ways of doing transactions and events and business logic workflows, right? You're like, how does that map into this kind of model when we're thinking about kind of these domains, right? How do we have logic across these domains, right? Where does that go? Is that another domain altogether? Is it not? And there are many different ways of, again, kind of approaching this problem. So it's not like, oh, here's a little diagram and this works, right? So it's a little bit different. But I think, and just before I close, I think that the future of GraphQL really depends on us being able to understand the why of why we're all using GraphQL and what we want from it before we kind of join the hype or propagate the hype and start cargo culting. And Rob Zhu from the first GraphQL Asia again had a kind of great talk around when you should not use GraphQL. But I think that is really important for us as builders and consumers of GraphQL systems to be able to kind of make sure that GraphQL evolves with us appropriately in the future. I'll end with this, which is a slightly bold vision, not maybe a bold vision, but maybe a slightly dreamy vision of where it would be amazing if you all got it together, right? And which is that, imagine that across the entire globe, right? Whether you're an organization or a team or a business or an individual, right? You have a certain amount of data and logic, right? And it takes no amount of work for anybody to take that data and logic and to just be able to share it, right, with anybody else, right? And it's super easy to consume, and there's no operations around it, right? There's just your data and your logic, and you don't have to operate it. And we're already, by the way, this is already happening in the world today, right? Because you're getting better and better databases as a service. You're getting more and more kind of compute as a service. You're just able to run a function and it works, right? And you don't have to think about, and the security kind of aspects of it are something that humans can understand, right? It's not so complicated that you can't understand. All of the complex stuff is baked into infrastructure. But all of the relevant stuff to you when you think about your security policies is something that you can understand. And again, this is what people are moving towards, especially where complexity is very high. But if this happened for every single thing, right, and every single entity, right, from all the way from individuals to like small businesses to large businesses, imagine the kind of productivity that we would unlock, right? We're not even at the beginning. It's like the internet, where we're all kind of communicating with each other. But now imagine that instead of that, it's this ability to kind of share domain information over an API with each other, right? That kind of API connected world is, we're still in the early phases of that kind of journey, right? And GraphQL can have an extremely kind of powerful role to play here. And to see that evolve as builders and consumers of GraphQL, I think is going to be absolutely amazing. But with that, I shall stop and close. And sorry if I went a little bit over my time, and apologies for my net glitching out. I'm not sure if you have time to take questions, but I'll be hanging around here and I'll be on Twitter. So please feel free to reach out to me and have a chat with me. And welcome to GraphQL Asia 2021 again. And I am extremely excited for the rest of the talks over the next 2 days, talking about web productivity as well. Thank you for having me, and have fun over the next few hours.
Thanks, Tanmay. Appreciated the talk. You got all my cerebral cortex working here. Appreciate it. All right, so our next talk is coming right up. This one is from Roshan Alexander. He built an intelligent caching layer, which he's going to talk about over a GraphQL gateway, leveraging the CDC patterns that he's put into place to serve millions of users with a fraction of the infrastructure costs that many often run into. Roshan Alexander is passionate about anything that is related to using technology, is a hardcore programmer, and loves working with robust distributed systems and highly scalable systems and startups, and has a thirst for learning new things and getting outside of his comfort zone. So without further ado, I give over the stage to Roshan Alexander.
Hello, everyone. I'm Roshan Alexander, and I'm here to talk to you about the ways in which Pratilipi have built an intelligent caching layer over our GraphQL gateway server to reduce the backend calls to our system, and also to reduce the latency of the APIs to a large extent. So let's jump right into the talk. So just a brief introduction about the company that I'm working in. So Pratilipi is India's largest digital platform connecting readers and writers in the vernacular languages. So currently we support 12 Indian languages, and we have 3 product lines: Pratilipi Literature, Pratilipi FM, and Pratilipi Comics. So just to give a brief glimpse of our scale, we have 3 clients. We have an Android client, we have iOS and web. We have a combined DAU, daily active users, of around 2 million plus, and monthly active users of around 25 million plus. We also have around 250,000 writers in our platform writing for us, and combined, they have written more than 2.5 million stories in the platform till date. For the backend services, we have around 40 microservices serving around 1.5 billion requests per day combined. Our resting data is somewhere around 5 terabytes plus, and we are a pretty lean team of around 15 engineers working across all these three products. So just to give a brief intro on where the GraphQL gateway fits into our entire architecture for Pratilipi. So we have a CDN plus web application firewall layer on the outside. You have the three clients. So once the request coming in, so we have an external load balancer that faces the outside world. And then we have an internal load balancer behind which all our services live. Say the author service, we have book service. So what GraphQL gateway or our API gateway in this case is a REST API gateway. So those are the layers that sits in between the external load balancer and internal load balancer and aggregates data from all the downstream services. So this was just to give an intro on where currently the GraphQL gateway fits into our entire architecture in Pratilipi. So now, why we even moved to the GraphQL? So if you see the first image, we already had a REST API gateway, and then recently we introduced the GraphQL gateway. So when you talk about this, there is many things that comes in common to everybody. Like when you want to move to GraphQL, the main reasons are to reduce the backend calls, the round trip time. The second one is to solve the problem of overfetching, underfetching. But here I'm just going to explain the things that we felt more than this that GraphQL has given us. So the first one was faster feature development. The thing was, if you want to create a new UI that needs a different data field, mostly the case is just that you have to add a new query in the front end, and maybe you might have to add new fields in the existing query. So your UI is already ready. In the earlier case, you have to build a new API for that. So the feature development has become incredibly fast with GraphQL for us. And the second one was reduction in code base size for the backend for front end layer. So after we moved to GraphQL, our code base size for the BFF layer have actually reduced to 1/5 of what it was earlier. It was like orders of magnitude reduction for us. The next 2 points, reduction in internal downstream service calls and faster API responses, they are the ones that will be the topic for this talk on how we actually achieve that. So just to make sure like we are navigating this talk pretty simply, I'll just add a sample schema that we have. So we have two entities in our system, book and author. So a book has a title and then has an author, and author has first name and last name. And suppose we have a sample query. So the sample query is get top 100 books in our system. That gives you back an array of books. Now, this is a sample client query. So the client is querying such that you get the top 100 books in the system. So you're getting the title, and for each book, you're getting the author and the first name, last name of the author. So let's put this as a sample scenario where you have a book, you have an author, you have a query, and this is the client query that you're calling. Okay. Now for the basics, so we have a proper resolver that says you have a query top 100 books that is internally calling get top 100 books, and you have an author resolver for a book that says for each book, this is how you have to get the author. So now you have the resolvers also ready. So N+1 query problem. So whenever I start talking about GraphQL to someone, the first question that they ask is almost like, how did you solve the N+1 query problem? Like, so just to give an example of what is an N+1 query problem, say the same query that we are going back, the same resolver will go a bit in depth. So here I'm saying get top 100 books in the system. Suppose that particular data is being fetched by one of our internal APIs that says /books sort equal to top and limit equal to 100. This could be one API call that will give you the IDs of 100 books in the system, in the book service. Now the second one could be for each book, how to get the author. So you're saying get author book.author ID. So here it is more of, okay, it might be another backend call to the author service saying /author/author ID. So this will get you the author ID for author details for that particular author ID. And this resolver will resolve the author for that particular book. Okay. Now if you see the count, now think about just one single get top 100 books query coming into the system. What is happening is you have the very first call going to the book service, this particular API that gets you the top books. That is the very first one. And the second one is there is 100 calls going to the author service, each call for getting the author of each particular book. That is this particular call, internal repository of author's author ID. Now, if you think about it, there was one incoming query from the client that actually translated into 101, like 101 queries in the backend. So this is exactly the proper thing about being a n+1 query problem in the system. Now let's take a sample scenario. Like I told in the very first slide, we have around 22 million daily active users. Now suppose each user calls this query once in a day. Even in that case, if you think the same numbers and like extrapolate it, book service will get 2 million calls, each call to get the top 100 books, and author service will get 200 million calls. That is 100 into 2 million calls for getting the authors for each book. Now if you see, this is 202 million just for this one single query. So this is what. So if you have n+1 query in your system, a small increase in your input count will actually explode in the actual downstream calls. So it's not something you can always have in your system. You have to solve it somehow, right? Now, there is multiple ways in which people have solved this n+1 query problem. I'm not going to be exhaustive on what are the different ways, but I'll just share the way in which we actually turned the entire problem upside down and made it to a benefit and made the system much more faster because of it. Okay, so this also goes back to a very first slide. Suppose I have already mentioned that we have around 250,000 authors in our platform. Now, if you see this particular screen, the author service calls is around 200 million to get the author details, right? So now, so you have 250,000 authors and 200 million requests. So what is this additional 199.75 million requests doing in your system, right? So that is a whole answer to what we are building. So if you have like just 250K authors and 200 million, the rest 199.75 million requests are actually duplicates. So if there was a way where you could cache this 250,000 authors, then the actual downstream calls will also be just 250. The rest, all the calls will actually be served from the caching layer, right? So that is exactly what we try to do. So we built a caching layer that is very near to the GraphQL gateway that says, say if you want to get, so if the resolver is saying I want to get the author with author ID 001, it will try to read it from the cache. If it is not there, it goes to the downstream service, read the data, then add it to the cache and serve it back to the user. Next query comes in, it checks if it's already there in cache, serves it directly from there, right? Similar to say 1002. So now the cache has two different IDs already cached for author. So now this is a very simple solution. You have a caching layer on top of your resolvers that is calling the backend calls, right? Now, the most difficult problem to solve in any caching solution is not exactly the caching, but when to remove it from the cache, right? So here I could give you an example. I have added two things to my cache that is near my gateway. That says 001, the name is Roshan Alexander, and 002, Rahul Ranjan. I have added two entities in my Redis for the gateway. Now I have an author service and say someone is updating the downstream data for the author service and updating my name from Roshan Alexander to Roshan Alex. It updated. But now if you see, this particular cache here near to the gateway has no idea that this has happened. Now what will happen is that the staleness occurs. Now to reduce the staleness, so there's always this trade-off. So either what you do is you put a very small TTL, say 5 minutes, and then you say it's a product call. Even if someone updates it, it's okay that you see the stale value for 5 minutes, right? So that will be the very less TTL. Or you say, I'm going to increase my TTL, but the product is okay with the staleness of it. Even if it's a stale for an hour, it is okay for the product. So there is always this trade-off. You have to either to select TTL or to select the staleness of the data, right? So there's always this one. So now technically, if we know whenever a backend data changes and if you could remove it from the cache, then you can ideally cache this data forever if you want, because it will never be stale. If you know the data changes, you can remove it, right? Now that is exactly where GraphQL Turbo is trying to solve, where you don't need to have that tug of war between the TTL and the staleness issue anymore. So I'll explain you how we did that. So we already have a system in our place called change data capture. So what we do is we have different services, and each service will be having their own data stores. It could be Mongo, it could be MySQL, it could be Neo4j, Cassandra, multiple databases. So what we did was we used DBCM connector. It's a DBCM Kafka connector. So what it does is it attaches to the database as if it is a fake, think of it like a replica. So there are ways in which the databases replicate between their master and slave. For Mongo, it could be oplog. For MySQL, it could be binlog. So they're like change stream files that is being written to them, right? So what DBCM does is it connects to these files as if it is also a replica, reads this change set data, and then pushes them to Kafka as a change stream. For example, I've given, so you have a book service. In there, the title is getting updated to my new title. So what will happen is there's an event that is generated to Kafka that says entity ID B001. The old value was my title. The new value is my new title. Similar to that, if I update my name to Roshan Alex, this DBCM is attached to the author DB also. So what it does is it streams another event to the topic saying entity ID 001. The old value was Roshan Alexander. The new value is Roshan Alex. So this way, so we have all the changes that mutations happening to your data is actually pushed to a Kafka topic where it's ready to consume. So this is the first part of the puzzle. So once you have this, so what we did was we implemented something as a wrapper over all these topics that reads all the change set events from these topics and say, so we called it GraphQL Turbo. So what that does is whenever it gets a particular event from a change set, we know how that maps to an ID from GraphQL gateway layer. So for example, here, if you see, if I'm saying B001 value changed from old my title to my new title, I know this GraphQL Turbo will know the GraphQL gateway caches this data with value as B001 key. So it knows, okay, I'll remove it. Now, similar to that, for author CDC Kafka topic, what will happen is if the name changes with ID 001, GraphQL Turbo will know, okay, this is a Redis DB and 001 is what you have to remove from the GraphQL cache. So GraphQL Turbo will watch all the changes that is happening in your system. Just remove it from cache. It doesn't even update the new value or anything. You just remove it. So the next time a new request comes in, GraphQL will read it from the source and update it to the Redis. Okay, so once this is done, then we are pretty sure we have like almost zero lag in the staleness of the data, because whenever the data changes, the data is also removed from the Redis as such. Now, this kind of makes it a very harmonious circle where you have your GraphQL query coming in, you check in Redis. If it is there, you serve it from Redis. If it is not there, you go to the backend service, you read it, then you add it to the DB. And whenever there is any change in the backend data, it gets pushed from the CDC to the Kafka topic. It gets read by GraphQL Turbo. It removes it from the cache. And all this process together, suppose it takes around say 20 millisecond or 30 millisecond, and depending on how that DBCM connector is efficient, it might take even a minute for us. So that comes the second problem, the millisecond latency. For example, say I am the author, okay, and I am updating my name from Roshan Alexander to Roshan Alex. I am okay if say 1,000 of my subscribers, 1,000 of my readers is seeing my name after a minute. I don't care about that. But when I am updating my name and if update my profile, I have to see it immediately, even without a millisecond latency. So that was a second challenge. So all this process was asynchronous. It could still take a minimum of 10 to 15 milliseconds, and the maximum of around 30 seconds is what you have seen in the system. So how did we solve that? So what we did was in the GraphQL resolver layer, so we added this additional check. Whenever if you want to fetch a resource, say you want to fetch the author data, you go and fetch it. And if the data is fetched from the cache, we do one additional check on figuring out whether the current user, that user we get it from the GraphQL context, if the current user is the owner of that resource. So if I am the author that I'm asking the data for, or I am the author of the book that I'm asking the data for. So anything, if you are the author of the resource that you're asking for, what the resolver will do is, it again goes, if the data is read from cache, it will again go to the source of truth. It goes to the backend service and fetches it again. So that way, your cache is not having, even if it has that latency of staleness, the actual owner of the resource will still be seeing the latest data that you have done. So there is no issues with him facing any issues that the data seems to be not updated even if you have done it. Now, summing it all up. So now how it happens is you have clients, they come through the CDN plus the WAF layer. It comes to our external load balancer. You have the gateway. The gateway have resolvers. They try to read the data from the resolvers, the data from the internal services by first going to the cache. If it is there, they get it from there. If not, they'll go to the downstream service, get the data, put it to the cache and give it back to the client also. And whenever some updates happen in the database side, they push it to the Kafka. Kafka pushes it to GraphQL Turbo. Turbo will actually remove those things from the cache. So this is like an entire harmony circle that happens to make sure everything is working with the needed product specifications. Now, after this, what were the future of it, like that we are planning to build? So one thing that I omitted while talking about solving the N+1 query problem was data loader. So why we didn't go with data loader is a thing for another session. But yeah, so going forward in the future, we have an approach where you have a data loader plus individual caching logic, where even if you want to fetch 10 authors that is not in the cache, you use a data loader, fetch them together, and then cache them individually. So that is one of the hybrid approach that we have in the future to even further reduce the number of calls to a backend system. The second one is a secondary cheaper cache with multiple times more TTL per circuit. This is also another implementation where, so currently we have our Redis as our caching. So what we can have is another secondary cache, say Redis has 8 hours of caching. Then we'll say we'll have another cheaper one, say Cassandra, that has TTL of say 2 days. So what can happen here is, so if one of your service is down, say your author service is down, so we do have circuit breakers in your resolvers. So say if it fails for 5 times in a row, the circuit opens and then it goes to the fallback. So what we can do is, if the author service is going down, we can use a secondary cheaper cache and say, okay, rather than going to the service at all, I'll get it from the cheaper cache. I'll read it from the secondary cache and then serve the users. The good thing about this is, even if like your entire system, like some part of your system is down, your users will still be able to use your system without facing much issues. They'll still not be able to do the write operations, but like 99% of the use cases in our system are reads. So the users will still be able to use the app as such. So yeah, so that was how we solved the entire thing with, so it was a combination of our existing CDC framework plus a intelligent caching that we built over the backend API REST layer. And all these solutions together, how it helped was, it reduced our backend calls by around 60%, and that also we implemented only in half of the system. That reduced the entire calls by around 60% in our system, and the API response times have improved like very greatly. That was because of mostly the 80-20 rule, because 80% of your data is what, 20% of your data is what 80% of your request might be accessing. So if all those hot data is already in the cache, most of your requests will be like really, really fast. So, and that is what we have actually experienced using this solution. So yeah, open for queries.
Oh, that was great. I really enjoyed that talk. And already there's a great question in chat, and I've got a few for you myself. In chat, Tanmay Bangali asks, how did you leverage, or how to leverage a CDN for caching, as they are usually made for REST APIs and cannot effectively work with GraphQL APIs? For example, the issue with like just getting a status code 200 all the time and things like that. And it goes on to ask, CDN usually look at that status code for caching, and this way, if it is enabled, GraphQL errors will also be cached, which they should not. And asks if there is a solution to this. And one of the questions that I had too was just kind of in a more general sense, like, why didn't you use, say, like query level caching also, or something like that? I noticed you had like the Redis cache in there and things. Could you speak a little bit to that? Like, what was the decisioning that you went through with all that caching?
Sure, sure. So to answer the first question, what he asked you was like really right. So CDN usually depends on the HTTP status code, and for GraphQL it is always 200. Even if like entire queries fail, you still get 200. So CDN layer that I just added as an entire architecture view, but for the GraphQL layer we just pass through from the CDN. So in the CDN layer itself we have the rule: if it is with /GraphQL, don't cache it. So it just passes through a server, and it's usually like only served from a GraphQL server. CDN is mostly for the static resources and some of the REST requests too. But even REST, if you don't leverage too much of CDN because of the issues with the cache invalidation. But the question, we just pass through it for GraphQL. CDN, we don't use it as of now. And yes, second question, if I remember it right, you were asking why did we go for query level caching and why did we go for the entity level caching? So query level caching has that issue, like similar to what I was mentioning for CDN also. So when will you know how to invalidate the cache? Say, for example, the same thing that I was mentioning in my talk about getting the top 100 books. So now if I cache the entire query of getting the top 100 books with their title, if I cache it entirely, it's very easy. So next time the query comes, I'll just serve it from the cache. But the issue there is, say if one of these books changed, say one of the book title of this books changed, when will I know I have to remove it from the cache? So it becomes really, really difficult for me to backtrack and figure out, okay, so this one book changed. Now this was part of the top 100 books. So I have to like remove it from the query cache of that particular get top 100 books. So it becomes really hard to say when to have that staleness or when to remove from the cache. That was one of the main reasons why we didn't go for the like entire query level caching. Though we do have it for some of the like high level meta level request and all, but we do there.
Cool. I see. One of the other questions that came up during the talk was, why didn't you go for the data loaders? What was the idea behind that?
Good, good. So I think the same thing that I mentioned in the talk also, like data loader is also another way in which you could solve the N+1 problem. And it was like a really good solution that was built by Facebook initially itself for solving this problem. So in data loaders, what it happens is, say you have like 10 queries that is going, say, give me details of each book, book 1, book 2, book 3. So what they'll do is they'll wait for say 10 milliseconds or 100 milliseconds. They'll group all these requests together, and then they know how to call them together in a batched API. So rather than calling single APIs to the server, they'll wait for some time, group them together and say, get me the data of these 10 books together. So that is how it usually works. But from my experience working with GraphQL and trying to move the infrastructure to GraphQL, some of the main issues that I faced with data loaders was, so the first thing was we were a very, so we didn't want to touch any of the existing services as such when we are building the GraphQL gateway layer over it. So if you want this batched API, so most of the services are built as CRUD. So they have like very basic CRUD services. So if you want to add a batch API on top of it, you have to actually go and change the underlying services. So that was one of the major challenges that we faced if you want to go for the data loaders. But along with that, there are so many other issues related to data loaders. So the first thing, or rather for a batched API, so the first thing was, maybe you can backtrack even to a CDN question. Like, how do we know if you're asking for 100 books and one book failed? How do we know why was it failed? It could be, say, if it was a normal single request, you could say 403, it's forbidden, or 404, the book is not there. But if you're asking for 100 books and you're getting back 98 books, you don't know what happened to the rest 2 books. So it becomes really hard in doing the error handling also if you're going for a batched API. So that was also another issue for data loaders. So there are like many other issues also that comes with data loaders, like similar thing with caching. So if you're getting 100 books, now if one of the books changed, how will you know, okay, this was my batch API, how will I remove this entire caching of this batch because one of the books changed? That could be one. And the other one is even the cache utilization itself will be like really, really bad even if you cache a batch API. Because say I'm asking for 100 books, I cache that request. Next time, if someone asks for 99 books, I can't use the cache because it's not the same. So that cache can only be used if you're coming with the exact same set of batched IDs that you called earlier. So the cache utilization becomes like way too less if you're going for a batched API. So these are some of the main reasons that why we didn't go with data loaders, but we do have a hybrid approach in mind where you get the data using data loaders and then cache it as individual entities, just like we have kind of like hybrid approach that we are testing out now.
Mm-hmm.
Good question.
Cool. Yeah, I've been thinking a lot about caching, so it's interesting to hear your perspectives on it. Everything from like the HTTP stuff to the, putting things out on the edge or whatever. So I'm always curious about other people's experiences with all that. One last quick question. I was pondering, why did you think about using GraphQL Federation in any of this?
So GraphQL Federation also internally solves some of these issues. Like we don't need to use a data loader and handle most of the stuff like getting the data from the backend service together. It solves some of these issues again, but that also I think boils back to our lean team that we are working on. So we didn't want to touch our existing services at all. So you already had a REST service. So our earlier architecture was we had a backend for front-end service that was mostly another REST service that was a blanket over all the other REST services. So we just want to replace our BFF layer as such, but we didn't need to touch like any other downstream services. So that was our motto, and that was one of the main reasons why we didn't go for Federation. But if we were building ground up, like all the services ground up, maybe we would have thought of Federation too. But it was a good question.
Cool. Yeah. Well, thank you very much. It's great talk. Really enjoyed hearing about your experiences. And now we are going to step into a short break, and we'll come back at 40 after the hour. Or
Thank you. Thank you.
Thank you. So we'll be back 40 after the hour IST, or 10 after the hour if you're in a different time zone, and we'll get back into it then. So talk to you in just a few. Oh, do that right now. Before we go to break though, I am going to go through the sponsors. So we have Hasura, where again, you can get 1 month off the standard plan. That's $99 for free if you go out to cloud.hasura.io and use GraphQL Asia as your code. And then we have Stackhawk, which currently they're having a raffle. From what I understand, they don't have a sponsor booth. So a little information tweak right there. And also, of course, Yugabyte. When you need a large scale geo-distributed high performance database, check out Yugabyte for your needs. And then Atlassian, you know them as the builders and maintainers and service providers of Jira, Confluence, Bitbucket, Trello, Bamboo, and so many more software packages. Give them a chat. And also they are hiring. So if you're looking for a job, go check them out. And we will be back in a short bit. And we're back. And our next speaker, who I am super stoked to introduce, is Nikhil. He works in ecosystem engineering at Yugabyte, leading the efforts on Yugabyte DB integrations with open source developer tools like GraphQL, Spring Data, RTDBC, and Kubernetes. He also works with the developer community on the adoption of distributed SQL databases in cloud native applications. Maybe you'll have a question or two about that. Before joining Yugabyte, he worked as a senior data engineer at Pivotal, championing the cloud native data APIs and in-memory data grids for Fortune 500 customers. He has presented at major developer conferences and loves to field all types of deep dive questions. The talk today, where he's going to get into GraphQL subscriptions specifically and talk about their broad adoption, but also how they're used in building event-driven microservices. Like any other tech stack, as end user traffic increases, app developers will be faced with all types of scale workload issues. And he's going to get into that along with many other topics around Hasura Engine, Yugabyte DB, and how that all intertwines around GraphQL to build solutions on Kubernetes that are highly available on a distributed SQL database backend. And with that, I give the stage to Nikhil.
Thanks, you all for joining. My name is Nikhil Chandrappa. I'm a software engineer at Yugabyte DB. I work in the drivers and ecosystem team of Yugabyte, where we work with integrating with popular developer tools like GraphQL, Spring Framework, Liquid-Base, and host of other ecosystem projects. In today's session, I want to talk about how we can build scalable and resilient GraphQL applications. In the process, how we were able to scale the GraphQL subscriptions linearly to 1 million subscribers using distributed SQL databases. I believe many of the participants for this workshop have exposed to GraphQL in some form or fashion, right? It's super easy to get started. There are a few popular GraphQL server implementations out there. You take a GraphQL server, connect it to a database, and then you're ready to design your GraphQL queries using GraphQL console, right? However, when you have to move these applications to production, you have to consider a few day-to operations like the scalability of your stack itself. Like whether your entire stack, say you developed an application using GraphQL, right? And your app went viral. All of a sudden you're having like 10x traffic, right? How do you scale your clients, the server, as well as the database? So currently what we are seeing is sometimes the bottleneck can be like the single node traditional databases you use. And we're going to see how we can address that using distributed SQL in today's talk. And the secondly, you have to have a resilient application, right, for infrastructure failures. Many of us deploy our GraphQL applications in the cloud, and as we all know, cloud zones or regions can go out, right? There will be outages of some fashion, right? For that, the same reasons, you need to have your architecture so that they are highly available against infrastructure failures. The GraphQL server itself sometimes is like stateless, and the database, which is a stateful application, also need to be HA. So that's where we feel distributed SQL can help us, like Yugabyte DB, right? Distributed SQL are the ones where you can scale out your relational workloads just by adding new node to the cluster. And also inherently, they provide high availability using the native capabilities of sharding the data. And if even the part of the database actually goes down, your entire cluster doesn't go down, or your app will not be affected. And like if you want to scale out your database, and if you want to scale out your GraphQL layer, everything will happen seamlessly without any downtime. So for today's session, we'll be mostly talking about Hasura GraphQL server and how Hasura GraphQL server and Yugabyte DB works together to build a scalable and resilient architecture. In order to just showcase these capabilities, right, we wanted to do a real world exercise. For that, we went ahead and we tried to linearly scale GraphQL subscriptions using Yugabyte and Hasura. So we all know GraphQL subscriptions have many use cases, right? Like it can be used for event-driven microservices. It can be used for creating dashboard purposes, notification. There's like a lot of use cases we are seeing currently where GraphQL subscription being used. And this was a really good feature for us to do some of these perf as well as the HA testing. For us, we wanted to simulate a real world use case. For that same reason, we took the e-commerce application where we'll have a bunch of users, and each users can have multiple user orders they can submit. So we simulated this, and we simulated a perf tool where we can have a number of user accounts, and each of them can get variable number of user orders. So depending upon like if you want to simulate a Black Friday scenario, you can specify the load for that kind of a scenario. That's what we'll be talking about, how we were able to scale today. So in our GraphQL set, before I actually go to the results itself, I just want to talk about the setup that we have for our benchmark exercise. From the GraphQL load generators, the GraphQL subscription simulators we have created, as well as the GraphQL engine, as well database, everything is running on Kubernetes, on a cloud native environment, which kind of simplifies how for us to scale out the entire stack. Like the clients, the server, as well as the database can scale linearly. That's what we wanted to showcase as part of this demo. Let me go ahead and showcase my demo itself. I'll be scrolling between few screens here. I'll be scrolling between a few screens. I will be using my presentation as well as I have my console, the terminal where we'll be walking through a few commands. Let me go ahead and walk you through my setup itself, right? If you see here, this is my Yugabyte DB cluster. This Yugabyte DB cluster is also running on Kubernetes. It's a live Yugabyte DB cluster. We are actively running workloads on it, the simulation we are talking about. And this is the one we are going to see how we can live scale this, as well as we are going to see how we can live scale the Hasura GraphQL engine, which is connecting to Yugabyte DB. So as you can see in the metrics, we have GraphQL subscribers. We already have around 25,000 subscribers, which is connected to the database. That's why you see some load on the database itself. And also we have a GraphQL engine, which is our Hasura GraphQL engine. And if you could see, there's like few tables we have already already registered with Hasura. And if you see my subscription query itself, it's pretty straightforward. Or what I'm saying is, I want to subscribe for a user account, and whenever the new orders is coming, right? So that's what I'm doing here. And let me go back. This is our setup on the database and the Hasura. If you see, there's like two tables that we are subscribed to: user account and user orders. This is the one where we are going to be doing perf testing. And if you see, like I have a subscription where we have around 25,000 subscribers actually running. Let me go ahead and start a workload, right? I'll start my workload. This is like new orders. New orders are being written to written into the system. I'm starting my workload, and if I go back to my database, I should now see new workload being written. If you see here, there's like new workload is coming to my system, and I can actually go ahead and scale out my database even with the live traffic. And even in such situations, my GraphQL subscriptions will be working fine. Let me go ahead and try scaling out my database here. I'll go, and it's as simple as just changing one parameter. I'll just change my database from 3 nodes to 4 nodes. This should go ahead and start my, I'll save this, and this should start creating a new load. So, and if you see here, my workloads are still running. So there is at no point in time, I'll have any outages in my database, as well as there won't be any outage for the GraphQL applications itself, because they will continue to run. So if you see here, I have new events coming to my subscriber, even when we are scaling out the database itself. So that's how simple and easy is it for us to create a cloud native GraphQL architecture where the entire stack is scalable. Let me go back to my slide deck to show how we scaled this linearly, right? So using this, we were able to scale this setup linearly, starting from 25,000 subscribers to 1 million subscribers, just by adding new nodes to the cluster and also increasing the number of Hasura instances. This entire exercise, whatever we have, whatever I showed now in this demo, is actually documented in a Git repository where we talked about how we scaled to 1 million subscribers, the entire setup, as well as we talked about the high availability, what happens when you lose a node. If you are interested in the detailed study, please go ahead and check out this Git repository. That's it, folks. That's all I had in part of this short demo to showcase how easy is it for you to get started with distributed SQL and build a resilient and scalable GraphQL application. And as part of this conference, we also have a booth. Please feel free to join our booth. And also we are hiring across the entire portfolio. We have the core database, the cloud, as well as the ecosystem. Check out our careers page. Thank you.
Always excellent hearing from Nikhil. If you have any questions for him about this presentation or Yugabyte in general, architectural or whatever, be sure to tweet at him at NikhilMCN on the Twitters, and he'll get those things answered for you 24/7, I hear. So our next speakers are duo. Sunitha has an overall of 10 years of experience in the IT industry. Currently, she is working at SAP as a senior developer for strategic procurement related products. She has experience in building enterprise and cloud applications for domains like healthcare, telecom, and procurement. Her interests are towards solving problems in microservices architectures. Kumar holds an MTech degree in computer science from NIT Suratkote, India. He is currently working as a principal software engineer for strategic procurement related products in SAP Ariba. He has an overall 13 plus years of developer experience from organizations like Oracle, JP Morgan, IBM, Software Labs. His expertise are in building enterprise and cloud application for domains like pharmaceutical, software tools, and procurement also. They are going to be speaking about the user experience, performance, scalability, etc. All of these essential elements for modern day applications with increasingly heterogeneous applications and consumers like legacy systems, multiple microservices, mobile application client, etc. Catering to each of them would be challenging as every user interface or consumer's fields of interest would differ, resulting on different APIs. So they're going to teach you how GraphQL comes to rescue to cater to the variety of consumers of this data without compromising on performance or user experience. So with that, I give the stage to Sunitha and Kumar.
Good morning, good evening, everyone. A warm welcome to the session on building high-performing applications using GraphQL. Myself, Kumar, and with me, Sunitha, we both work for SAP and based out of Bangalore, India. So we'll start with a bit of context about our domain and environment, and then we'll look into the pain points we had or still have today, and how GraphQL is helping us in the journey towards improving the performance and scale, and also the future roadmap for us. We still are really early in this journey of GraphQL. The GraphQL itself is still fairly a new technology, not too new, and we are only been using it recently. So hence we are still learning, adopting, implementing, and have a lots on our plate for this journey. So why should we all care about GraphQL? Why is this conference hosted? And so many speakers, listeners, workshop and all? Because at the end of the day, we think GraphQL is really good for faster development and team communications and also with better performance. Let's understand more during this talk. So who we are? So within SAP, we are in a procurement domain where buyers and suppliers are connected for goods, materials, and any sort of items or services as needed by the buyer, which would be fulfilled by suppliers or a set of suppliers for a great deal. So when we say a good deal, so good deal with respect to cost, quality, thus minimizing the spend for the entire organizations. So we have components like sourcing, contracts, supply management, and a lot more. And all of these components are on cloud. So we are a very small group within this whole ecosystem. So how are we today? So we are a huge monolith legacy system with multi-tenant solution on cloud and moving towards distributed and microservices architecture. So we are breaking the monolith into smaller microservices, and most are built as REST services in different technology, which also talk to each other. So currently our users are served through a legacy system and also through newer services. So few of the pain points we and most of us have. So to load a single page in production, sometimes we'll have to make like 15 to 50 API calls. I'm not telling that this has to be reduced to a single call, but still 15, 20 calls are a lot. So back into front-end design pattern. So for some of the use cases, we also have APIs built specifically for the front end to provide the exact data as the front end needs. So like aggregating the data from different entities as needed by the client using a single API call. Duplicate APIs. So we have a number of use cases across teams that needs the same or similar data or entities. Each of these teams have written their own APIs, resulting in a lot of duplicate code, which not only results in high maintenance, but also the fixes actually needs at multiple places. Backend and front-end team communication has always been time-consuming. So generally, when a feature is started, the backend team gives a rough info to the front-end team about what an API could return, but the front-end team has to wait a little longer until the API is kind of completed by the backend team so that they can actually start the core integration part. We are also hit by the overfetching of data. So this results in the poor user experience. So even if we need just a couple of fields, so the REST API endpoints ends up returning the full details of the entity. Since we have to fetch a lot of records in few use cases, the response times are really bad. So especially when the internet speed is quite low. And versioning has always been a pain. So we mostly have internal private APIs, but we also have external ones which are exposed through open APIs. So we have challenges with versioning, backward compatibility, and bumping of versions, and the whole process itself is painful. So like, do we have to bump the versions of just one API or the group of APIs? And how would the consumers know about these newer versions of the API in an easiest fashion? So with most of these above pain points, the load on the legacy system is unnecessarily more, causing out of memory sometimes, slower response times to our end users, and poor scaling.
As Kumar mentioned, we have legacy system and few microservices as in the diagram. The user request could either be served by microservice or legacy system. You can also observe some communication among services too. These services expose data through REST, hence the pain points as we saw earlier. As the use cases evolved, we had to take a step back and analyze the design before we went ahead with adding more APIs to the existing service or building a new service. We had also observed performance issues while supporting larger events with the above ecosystem. After some research, we found GraphQL as an alternative to the REST. So basically, we had two options. Either continue to use REST and add services to above ecosystem, or try GraphQL and adopt a new strategy to reduce load on legacy. Initially, we were a bit skeptical to adopt GraphQL due to some of the known challenges by GraphQL. Like most of our teams were comfortable with REST and there was a learning involved with GraphQL. So we had to think, do we have time and resources to invest, learn, and adopt GraphQL? Client-driven approach of GraphQL could sometimes pose potential threats on our server. One of the example is client may query large, deeply nested query that are expensive to compute, and this could interrupt our network or bring it down altogether. We need to have a plan to address them, and these were the additional asks in order to protect our GraphQL server. It also requires incremental migration as multiple teams are involved. In sourcing, we deal with a lot of hierarchical data, such as items hierarchy, regions, commodities, etc. And we know GraphQL doesn't support recursive query of unlimited depth. So we had to change the way UI is designed to deal with recursive data. It can be handled easily in newer service, but can this adoption be easier in all other existing microservice? And of course, the known challenges with caching and N+1 problem. Still, we did give a try to GraphQL. Reasons, let's see. Though it had an initial learning curve, once comfortable, we were able to speed up our development using GraphQL, as client and server could work parallelly, unlike before. One of the main reasons was to solve the problem of overfetching. REST responses are known for either containing too much data or not enough of it, thus creating the need for another request. GraphQL solves this efficiency problem by fetching the exact data in a single request. It is a best fit for complex systems with multiple microservices. When migrating from a monolithic backend application to a microservice architecture, our GraphQL API gateway can help handle communication between multiple microservices by merging them into one GraphQL schema. While each microservice defines its own GraphQL schema and has its own GraphQL resolvers, one GraphQL API gateway consolidates all schemas into one global schema. With this, we do not have to duplicate the APIs across teams. Also, GraphQL keeps documentation in sync with API changes. As the GraphQL schema is tightly coupled with code, whenever there is a change in field, type, or query, the change is reflected in schema, so do the docs. This directly benefits developers since they have to spend less time documenting their API. Versioning. GraphQL eliminates the need for versioning by deprecating APIs on a field level. Aging fields can later be removed from the schema without impacting the existing queries. By using a single evolving version, GraphQL API gives apps continuous access to newer features and encourages for more cleaner and more maintainable server code. Achieving backend for front end using GraphQL seemed more promising with reusable code. Let's see how our architecture looks after we adopted GraphQL. Here is the high-level building blocks involved in our solution. The two circles in green shades represents new microservices which are using GraphQL. The design strategy what we adopted was we did not want our new service each to be like any existing service in the ecosystem. Also, we identified most of our services deal with some common parts of sourcing event data. So we decided to sync that data in a different service, let's call it as a persistent service, and make all consumers for this particular use case to reach out to the newer data service. For this solution, we built GraphQL APIs on legacy, which would expose data to the persistent service, and we have a mechanism in legacy to update persistent service whenever there is a change in sourcing event data on legacy, so that persistent service could request only the data what is changed. As the consumers of legacy system for this particular use case would now reach out to the persistent service, so the problem of overfetching is solved for this use case and the load on the legacy system is reduced drastically. Next, coming up with performance numbers, which is crucial step before you move your application to production. One of the basic performance metric is to monitor API response time. GraphQL provides instrumentation interface that allows developers to trace GraphQL APIs. It gives insights on how clients are using fields from our graph, also how long each request is taking. Initially, we started with field level tracing using a tracing instrumentation class from GraphQL Java. It worked well with less data, but it started giving out of the memory with large events. So for now, we capture only time taken by each request using instrumentation interface. You can publish these metrics to any monitoring service. We already use Datadog, so we publish these metrics to Datadog. This lets us to identify what part of the resource fields are more slow and needs further investigation to optimize the queries. We can also log these metrics and publish to Cloud Health. Instana tool is good for more complex ecosystem with multiple GraphQL server and API gateway. Here are the few snapshots from our Datadog dashboard. We are monitoring number of GraphQL requests received and number of failed requests at pre-GraphQL stage, which could be due to invalid or invalid customer or could be for any other valid reason. This dashboard also gives us insights on how our services are being used. We also publish API response metrics, which helps us to monitor query performance. There is an option to drill down metrics with respect to each query to get more insights on query performance on datewise. We see fair performance improvements with GraphQL for most of our APIs, and number of requests to the server has reduced a lot. We are in the process of collecting all these performance metrics. As of now, it looks very promising.
As per details from Sunita, what we have achieved so far is very small. And here is how we want to be. In this diagram, we can notice individual services exposing non-duplicate data like service A, service B, service C, and service D. They also expose GraphQL schemas to the schema registry, which is on the left side of the diagram. The client request would always go through GraphQL gateway for not only for new services, but also for the legacy system if there are any. On a high level note, all individual microservices would be a standalone GraphQL service and would be developed by developers with domain expertise. Developers define their own GraphQL schema within the GraphQL Federation. And this federated one GraphQL schema will be managed within the schema registry as defined by these individual microservices. The schema registry now has the combined schema of all the entities, thus allowing one graph for the entire group or organization. So it exposes CRUD APIs for the schemas, which are used by developer tools and CI/CD pipelines. So it is responsible for schema validation, both for the individual schemas and also for the combined schema. Lastly, the registry composes together the unified schema and provides it to the gateway. And this GraphQL gateway is primarily responsible for serving GraphQL queries to the consumers. It takes a query from a client and breaks them into a smaller subqueries, which is nothing but a query planning, and executes that plan by proxying calls to the appropriate downstream microservices. So we saw where we want to reach, but how do we reach there? So one needs to follow a set of principles that help us to take to the destination. So I'll talk about each of them at a little higher level. Integrity principles to begin with, to ensure that the graph is well-defined, it's stable and consistent. So by having one graph, so we can maximize the value of GraphQL, like more data and services can be accessed from a single query, and implementation cost is minimized a lot because the GraphQL implementation work is reused across teams. And also the central management of the graph would help to have unified access control policies like authentication, authorization, event tracing, and few other stuff can be done at a centralized place. The federated implementation is a must over single service and code base. As we know, the monolithic architectures are difficult to scale without having highly specialized infrastructure, and the data graphs are no exception. So instead of implementing an organizational entire data graph layer in a single code base. So responsibility for defining and implementing the graph should be divided across multiple teams. So each team should be responsible for maintaining that portion of the schema and which exposes their data and services while having the flexibility to develop independently and operate on their own release cycles. So tracking the schema registry. Just like it's important to track source code in a version control system, it's also important to track the definition of your graph in the schema registry. So there should be a single schema registry for your company. So the schema registry should become the central hub of the system, powering developer tools, workflows, or any business processes that would benefit from the awareness of the data graph and any changes to it. So this allows parallel software development process across multiple teams. So let's take a look at the agile approaches, which helps in rapidly rolling out the query and continuously adapting it to the changing needs. So it may be tempting to define the perfect schema ahead of time for the entire organization's data, but the true path to the perfect schema is to make it easy for the graph to evolve in response to the actual needs. So, and also we should iteratively improve the performance rather than optimizing every possible use of the graph. The focus should be on supporting the actual query shapes that are needed in production. Once the query is in production, its performance should be continuously monitored. So if this principle is followed, problems should be easy to track back to the service that is not behaving as expected. GraphQL empowers developers with metadata. A major part of GraphQL's value is the massive productivity boost that it gives to its developers. So some practical examples of the power of data graph aware tooling include developers can enjoy live documentation of the entire available graph data and services right in their editor and always up to date. Information about deprecated fields can be broadcast into the editors of developers together with suggested alternatives. The estimated cost of a query can be shown to a developer as they're actually typing based on the live production data. And all this benefits help in empowering the developers. And there are a lot more benefits with respect to the metadata. So let's take a look at the operational principles. The access control. Authentication and authorization are integral part of any system. So authentication is generally through auth token, JWT tokens, or through some other means. And authorization is about who can access what data, right? So should this authentication be built in the middle tier or in the GraphQL gateway or within the individual services? The same goes for authorization. Demand control. So it is a common mistake to allow users to perform any possible query regardless of the cost, with no ability to manage its impact on production systems, as a query could access a wide universe of services and the cost of the query can vary multiple orders of magnitude. Logging is an important part of any system. So a wealth of information can be captured about each operation that is performed on a graph. So was it a read operation? Was it a write? Was it a delete? What fields were accessed? How the operations were actually executed? How it performed, and a lot more. So instead of plain text log, it should be captured in a structured way to help readable by machines, which can be leveraged later in multiple ways. So it's always recommended to separate out the GraphQL from the service layer. So most data graph functionality should be factored out in a separate tier that sits in between the client and the services, leaving each service to focus on serving the actual needs of the client. So this tier, which can be composed of multiple processes, performs functions such as access and demand control, federation, the trace collection, and also caching. So some parts of this tier will be GraphQL specific and require deep awareness of the data graph, while functions such as load balancing or client authentication can likely be performed by systems that are already in place. Last but not least, we are also exploring Spring Web Flux in conjunction with GraphQL, which should allow us to scale better in the production systems, as the number of servlet threads would be minimized to a large extent. So I'll leave it to you to explore more about Spring Web Flux. with this, we come to an end of this presentation. We also have plenty of links shared here, but as you know that there are a lot of information already available on the internet. Thank you very much for patiently listening to our talk, and we would like to hear more from you. Thank you.
Thank you so much for that excellent talk. We've already got some questions lined up for you. So we'll jump right in to get as many of these answered as we can. Suvik asked, how does the GraphQL gateway decide which part of one graph schema point to which Microsoft for which response?
So in the world of microservices, so we have something called service discoverability. So within the gateway, so you know what queries or what fields should be resolved to what entities. So that's exactly, we have it within the GraphQL gateway as well. So for example, if you want to resolve, let's say, user, so that has to go to user entity. So there's a configuration which says that, okay, user entity is part of this microservice. So that's handled internally. So it's more of a configuration stuff that you need to just plug it in.
Okay, yeah. So a follow-up to that question, as Suvik asked, is there a business case for schema-based access control around some parts of the graph being accessed by only certain clients or anything like that?
It depends on use case to use case. Schema based. So I mean, it cannot be decided. Let's say at a pretty much high level like schema or something. So it depends on maybe the domain or maybe the entity or I mean what part of the data that you're touching with. So if you want to have that restrictions within the gateway level or the schema, you could do so. But I think the brain should be within the lower level domain services. So the roles or the access control, they would actually know it better. It's not the same across the entities. So I would say we should probably leave it to the lower level. So Sunita, do you want to add up any more?
Yeah, just to add on to that, we did not had any use cases where we had schema level control on the role. But we did have use cases related to the UI. Basically, we build a UI. We have a UI, and the backend is built using the GraphQL server. And there we had a certain requirement where user role did matter. For that, we followed different approach because this is not really at the schema level.
Gotcha. That makes sense. Yeah. So one of the things that I saw in that triggered a question to me was, how did you go about managing the query planning, or what were your thoughts around what you wanted to do around query planning and execution? I noticed this under the integrity principles slide. Could you speak to what you want to do in that regard as development continues and application use continues with GraphQL?
Okay.
So, yes, Sunita, go ahead.
Okay, just to set the context, one of the challenge what we saw is currently we have started with a small part of solution, and we do not have any API gateway. But the problem what we saw is our microservice is getting some part of the data from one of the other service that is called persistent service, and we also have a legacy system. So and we, I mean, the consumer, that is our service, doesn't know which part of the data is for which, and we are combining that query and we are sending it, and we do see a little performance lag in that. That's when we started realizing, okay, this is some common problem which we could face when we start migrating existing microservices to the GraphQL. And as Kumar mentioned, we will be having these domain-specific services. That way, we will have our API gateway. Even though as a client, we will send the query asking for all the data, our API gateway will take care of figuring out, okay, which field should go to which, and we are hoping that should help us in reducing the latency.
Gotcha.
Right.
Okay.
So just to add on to that, so basically this is something that the Federation spec talks about. So there is also already a open source implementation from Apollo. So Apollo Federation it is called, and there are like few companies who are actually implementing their own Federation implementation. I mean, like companies like Netflix and others have been doing that. So how it should ideally work is like, for example, during the query planning, so you know whether it can be a sequential call or some calls has to be parallel calls. I mean, why do you want to do like concurrent calls to improve performance? So that's something which would be part of your spec implementation. For example, initially I say I get me all the messages. So once you got the messages, so that for every message, probably you have to get like 10 other entities as part of it. So getting the message is a single call, but 10 other entities that you're getting, those has to be a parallel call. So that would be your query planning. So once your query planning knows so what all would be sequential and parallel, so then it's about the execution. So once you execute it, so then once you get back the response, you combine them all together and give it back to the caller. So
Gotcha.
that's
Okay.
the kind of a high level, but we are still in the journey of implementing that. So we still don't have that.
Well, excellent. Thanks so much for the talk, Sunitha and Kumar. Appreciate it. Have a great night. Enjoy the conference.
Thank you. Thank you everyone for listening to our talk.
Yeah.
Thanks, everyone.
So next up, another word from our sponsors, and then we will take a short break. Hasura, as you know by now, we just released a V2.0, and that's out there. And you can go out to our cloud offering and get the standard plan for 1 month for free with this code, GraphQL Asia. Just go to cloud.hasura.io. And then also we have, whoops, I'm getting click happy, StackHawk. So they have a solution that they have built, an application security scanner built on Zap, proudly so. And you can manage your security and testing during your builds, etc. They help you with that. And they're currently having a raffle. So go out to their site and check that out. And then, as you heard about recently, Yugabyte. They are a geo-distributed high-performance web scale database. So when your database is getting big, you know who to go check out. Give Yugabyte a look. So head over to the sponsor booth too if you have any questions, comments, etc., or ping Nikhil on Twitter. That's where he likes to answer those questions 24/7. So, and then we also have Atlassian. They are famous for the world-renowned Jira, Confluence, Bitbucket, Trello, Bamboo, and so many other great products. So go check them out. They are also hiring engineers in India. So if you're looking for a job in India, go give them a chit chat. And with that, we will be back shortly and are going to take a short break for now.
Things are getting complicated. Nothing's gonna stop this shit from sinking down. Think we need some mediation. I get it all for you. Why the hell do I fall for you? Baby, 12 a.m. you're dodging all my phone calls, baby. Why ask me? You already know it all, baby. Don't you play around with me tonight. If we go in it, baby, don't do it tonight. If we go in it, baby. Don't do it tonight.
Hello, everyone. We're back. Let me begin by introducing myself. My name's Tyler, and I'm responsible for looking after community at Hasura. I'm also responsible for, at times, stepping in for folk like Adrian when time zone means it's time to sleep. So I'm super excited to join to help wrap out the end of today's session, and then we'll be splitting time again tomorrow. With that said, let's go ahead and dive right into the next talk, which is entitled Adding Bleeding Edge Tech to Archaic Government, GraphQL for GovTech. Bharat, as part of the Central Tech team, which is a government consultancy that's working in 4 different states in India, attempting to create a culture of using open source, scalable, and bleeding edge tech for government use cases. So far, they've enabled tracking and monitoring student and teacher attendance in all public schools and building technology architecture that's behind it. But rather than me telling their story, let me allow them to tell their story. So Bharat, the stage is yours.
Hi everyone, this is the GraphQL for GovTech talk. I'm very excited and very grateful to be here talking about my work with technology and government, both things I'm very passionate about, and somehow, fortunately, they've intersected for me. I really couldn't have done a better job at describing my talk than the conference page. So that's my introductory slide. It's not a very typical tech talk. So there's going to be a lot of context that I'm going to have to set. So before we jump into that, let me just quickly talk about myself for a very, very short while. I'm Bharat. I work at Samagra, which is a governance consulting firm in India. And we work with states or provincial governments and in an attempt to improve the quality of life of citizens through better governance. That is the mission. All right, so let's dive in. Okay, let me just, yeah. All right, so this is not a very typical, as I just mentioned, it's not a very typical engineering conference talk in that it's talking about a sector that's not very well defined, that's not very frequently talked about. What is GovTech? Is it even a thing? Or is it a term that I've just invented? So I thought it was important to spend some time defining the contours of what GovTech is, how it has come to be what it is, and what we at Samagra are doing inside GovTech, right? So we'll trace the evolution of GovTech through 3 phases of its development, and these 3 phases roughly map to the last 40 years of Indian history, right? So the first phase, or roughly the late 80s, early 90s of technology inside government in India was the computerization phase, right? So computers began coming into India, began coming inside government offices. So if you had forms that you would typically buy from the local government office, these became Word documents that you could get off of floppy or a CD and so on and so forth, right? So that was the level of computerization that we saw in this time. Now, following that came the era of digitization. And what that meant was, so if we take the form analogy from the previous slide, it became that instead of getting it from a floppy disk, you could now download that form off the internet, fill a part of it, and then upload it back, right? So in most cases, the entire service would not be completely digitized, but at least a part of it you could fill online, and then eventually you would have to go back and queue up and complete the process, right? But digitization began to creep in passport offices, PAN applications, and so on and so forth. So tech in government became limited or became digitized, right? Another final piece of the jigsaw, which is very important, is public digital infrastructure. And this is so new that it's not a term that is very easily understood. So I'll try and explain what I mean from public digital infrastructure. By public, the idea is that this is government owned and it's transparent. So if there are specifications, there are going to be comments, and there are going to be consultations from the public at large, right? And from digital infrastructure, what we mean is that these are not products. These are services and facilities, just like physical infrastructure, which is available for people to do their own thing with. Similarly, this is digital infrastructure that allows people to use it and then build on top of it, right, in a modular fashion. So continuing the form analogy, what this meant is that instead, now you have digital infrastructure that allows you to download forms, use your phone. The applications can fetch data from different databases, so they're interoperable. You can sign them through digital identity. You can pay through financial pipelines that infrastructure has built. And finally, you can complete the application all virtually, right? This is enabled, this is powered by different examples of digital infrastructure that we've seen come up over the last few years, right? So what is the GovTech ecosystem? It's a motley crew of organizations that are trying to build open source components inside government, and Samagra is just one of these. Since it's not a very a space that will see consumers and customers very often, so it's more collaborative than competitive. But we at Samagra are one of these multiple organizations trying to build open source tech for governments. Right, so we've had enough context. I think it's time to dive deep into what we're here for. I'll talk about two case studies in particular. These are two states that I've highlighted in the presentation. I'll begin with the first one, which is the northernmost of the two, which is Himachal Pradesh, which is a hilly state in the foothills of the Himalayas. Now, what we built here over the last 4 years that we've been working in Himachal is digital public goods for school education. And when we came here, there were a number of challenges related to technology in school education in the state. There was no unified student database. It's a remote, parts of the state are very, very remote. So student-teacher communication is a challenge. And finally, there were no systems at all to monitor progress, to monitor whether students are gaining learning levels, on if the learning outcomes that should be met are being met at all, right? Now I'll go through the solutions that we've developed for each of these challenges over the past 4 years. And we began with infrastructure for data collection, right? So eSambad is nothing but a mobile app that's built through open source tech for teachers to be able to collect data and feed a student database. So what we've done through eSambad over time is build a Postgres database that is the largest and unified student database in the state. And leveraging this data, we've eventually gone on and built systems that enable authorities and administrators in the state to monitor learning level progress, right? And a number of other things related to students in school education. Right, we'll move on to the next stack, and I've purposely created the slide very similar to the one earlier, because the idea is that it's almost exactly identical. And that is the hypothesis that we've verified over the last couple of years, is that if you build systems and components that are configurable and extensible enough, if the use cases are going to be very, very similar across states. So in some sense, the analogy is with large enterprises. If you crack one, you will eventually be able to crack all of them, right? So using almost exactly the same stack, we deployed public goods for school education in the other state, Haryana, right? So the use cases are in some cases identical, in some cases they are dynamic and very new, but the components that we wired together and deployed differently in different states are able to handle both at the requisite scale. An example of this is COVID patients and employees level, district level reporting of cases in the state. So a very dynamic use case being managed through the same stack. I'll end with learnings that we've had deploying GraphQL in perhaps the greatest enterprise of them all, government. And I'll start with the challenges. And one challenge that you might expect is migration. So government, like any large enterprise, has its own systems that they've been running on, particularly Microsoft SQL Server, very, very popular in most governments. And the fact that it's not very easy to migrate, not just the tech of it, but also the know-how and people to maintain newer systems is a challenge. What I see on the horizon is larger organizations building things, for example, Amazon, which is just open sourced Babelfish for Microsoft SQL to Postgres migration. So that is a big space that is going to see a lot of work for the GraphQL ecosystem to prosper. And the second part is community. So GraphQL exists because of its active community, but sometimes the features that we would want to prioritize for governments are not the ones that are being prioritized by the community. And that is, of course, a common challenge for open source systems. I'll end with the benefits, and of course, these outnumber the challenges by far. The first is it's fast, and I don't mean fast in the performance sense, which it is, of course, but it's easy and fast to set up. We've had this belief coming from government offices and tech system administrators when we say that we can set up a database, a dashboard to visualize large amounts of data in a week. Because typically this is contracted out to vendors and they take months and they build proprietary software that costs a lot, right? So we're building free 5 days and it's difficult to accept. It's configurable in the fact that you can work with any system, any stack. You're not dependent on a particular stack or a particular library to work. And finally, it's scalable in the fact that not just from state to state because it's extensible, but also when we move from a state to a state, we see 10x the scale, and yet we're able to manage. We've been able to manage, that's what we've seen. And going forward, we're going to be deploying the same stack, the same components in a state that's 10x larger than both of these. And we're very confident of being able to meet those challenges and those use cases through GraphQL and through the stack that we've developed. And with that, I come to the end. This is Samagra's tech in the background. So people in the GraphQL community who want to contribute to GovTech, do give us a visit. Thank you so much, Hasura, and thank you so much, GraphQL Asia, for having me.
GovTech, the idea of a sort of archaeological exploration of what is happening in government by looking at technology adoption and how we can improve it. I find that incredibly intriguing. Bharat, thank you so much for your time, for speaking with us. If anyone does have questions, please find Bharat on Twitter and he will be answering questions there for you. So up next, we approach the final talk of the day, which is going to give us the opportunity to take some of the concepts that we've learned and to put them into practice. I was really excited when I saw this abstract because it begins with the description: when your infrastructure grows and your APIs get out of control, your manager tells you to implement GraphQL, and then what? This talk is designed to show us the way to explore the world of data streaming in context of Hasura and Apache Kafka. Wojciech, who's going to be speaking, writes GraphQL backends for a living, and in their free time is creating new ideas for GraphQL front-end libraries and tools, and has been maintaining numerous libraries, creating starter templates for GraphQL and enterprise developers. We will have some live Q&A at the end of this talk, so please put any questions that you may have into chat, and I'll get as many of them addressed as I can. So with that, Wojciech, welcome to the stage. It's now yours.
Hello, my name is Wojciech. I'm software engineer at Red Hat. Today we're going to talk about real-time GraphQL for complex backends. We'll draft possible architectures involving Apache Kafka and GraphQL CRUD engines like Hasura. Let's get started. At first, we're going to talk a little bit about CRUD engines, the way you can adopt them and use them in production, what they give us, and why we often choose them. Then we'll cover many possible ways for us to adopt the GraphQL. We'll talk about benefits and drawbacks of those. Then we are going to talk about Apache Kafka and how it can transform our ways to build the GraphQL API for existing backends. Finally, we'll try to provide some inspirations for reference architecture and ways that you can adopt Apache Kafka, CRUD engines, and GraphQL. Let's start our journey with a story describing a typical GraphQL adoption process. This story is based on one of the projects I know, but we often see the same similarities in the companies adopting GraphQL. So let's imagine that we want to build this application that will consume GraphQL API. GraphQL is very often used in a greenfield project that push the boundaries and use the modern stack. At first, we need to evaluate different solutions and technologies that will fit the best to our existing skill set. As developers, we need to decide if we're going to use a CRUD engine, framework, or integrate GraphQL into our current project. We will try to build a GraphQL API on our own. We'll need to focus on multiple challenges and face possible problems at the beginning. This is why we pick CRUD engine solution like Hasura or other projects that offer similar CRUD capabilities. Using CRUD engine will give us this instant GraphQL API that we can consume with minimal boilerplate and architecture challenges. We can develop project faster, get to know GraphQL better, and gather praise at work. Sadly, if we're working with a wider company ecosystem, our project needs to integrate with those at some point. Our POC data now needs to work with the live data that's also accessed by other legacy systems. At this point, we see developers, rewriting their application to CRUD, and using this self-assembly solution. In this talk, we're going to focus explicitly on this use case and prove that you can still effectively use benefits of the CRUD engine with existing backend. As a solution for this problem, we're going to explore architecture patterns that use CRUD engines and Apache Kafka. Before we talk about architecture that uses CRUD engines, let's discuss why we want to use them in the first place. So CRUD engines gives this GraphQL API for data. You can also include your business logic, get event hooks, authentication, and authorization. While in this talk, we don't have a time to go to details with specific CRUD engines, for all of them, we kind of get the same benefits. So we can get a project running faster. We don't need to think about assembling different technologies. And eventually, we don't need to think about GraphQL schemas, queries, resolvers, and all the boilerplate that comes with GraphQL. If we look at the architecture of the CRUD engine, we typically see some open source database, CRUD server, that does this all heavy lifting for queries and provides some way to put the business logic. Then we go in directly to the client. And if we try to publish, and push this model to large organization, we might instantly hit the challenges related to integration. Suddenly, your GraphQL API is just one way to consume the data and needs to coexist along many RESTful APIs, be proxy, working with legacy systems. We could have multiple data sources that may not work at all with the CRUD engines. Once we hit the problems with adopting CRUD engines, we often look for other ways to implement GraphQL API. Let's study how we can build GraphQL API without using CRUD engine and discuss the problems that we can encounter when we do this. Most often, when I talk with architects and project leads, I see this tendency to adopt GraphQL wrapper rather than CRUD. There are many good reasons to go with API wrapper for some of the use cases. However, we need to be aware of the many trade-offs when doing it. A wrapping GraphQL layer can cause some unexpected performance problems. What's worse is that we may not be aware of the challenges till we fully invested in the wrapping API. Our API might be hard to wrap if it returns different objects depending on the state, which is not uncommon for REST APIs. This way, we can end up with something called GraphQL union hell, where a schema will need to define a large set of GraphQL unions to be functional. If you're choosing GraphQL to establish an API contract between the client and server, wrapper will give you this false sense of the contract, as schema will be dependent on the RESTful API. There are a couple tools that will help you with these challenges, like GraphQL Mesh, but my personal take is that you can just avoid using REST API wrapping in your organization, then better, right? Good example of typical issue when adopting RESTful wrappers is when our backend is not reading what user wants to query and fetching entire data set. If our resolvers are using multiple data, like data sources, we will often need to do those unnecessary queries. For example, client side may use user's query on a homepage and fetching only the name. However, our backend may still make several calls to fetch the full user object. Eventually, our GraphQL resolver layer mapping logic will become this very complex and limit our innovation on top of the GraphQL schema. If we want to integrate with GraphQL into current server side, we can often go with self-assembly path. This is a good way if you already have strongly opinionated stack that you want to use and you're familiar with the GraphQL. There will be multiple challenges related to this approach. Suddenly, we need to deal with this efficient schema design, error handling, picking frameworks, or even more advanced use cases like compiling queries or cache. If we want a CRUD engine with GraphQL, let's talk about possible ways we can get it into our backend using Apache Kafka. Apache Kafka provides fast and scalable publish subscribe engine. Kafka somewhat differs from other publish subscribe system by a number of factors. It works great as a general lock of events, which fits well with the data streaming and CRUD. It has additional features that other queues missing, like storages, offsets, consumer groups. This allows developers to scale and consume messages that were previously consumed. Additionally, it's really easy to scale and route your data. When I have started exploring Apache Kafka, I could not find any reliable example how to efficiently use GraphQL with Kafka for full-stack developers. Many community libraries using single topic and partition architecture as a way to implement queuing system. Apache Kafka is Java-centric, with smaller set of libraries available outside the Java. If we go back to our overly simplified CRUD engine, in the diagram, it will be hard to see how we can connect publish-subscribe model, right? Apache Kafka doesn't make much sense as, CRUD engines will not interact with it. We can have our own custom logic to produce and consume the messages, but we'll miss all the processing and updates happening on a CRUD engine. In this design, we're going to use Apache Kafka producers and consumers to interact with the database. We can consume events from other legacy systems and insert them into the database as a form of projection. We can produce the messages based on what's going to be changed in the database. Produced messages can be consumed on a client using GraphQL subscriptions. Additionally, we could add many extra features like text search, cache invalidation, CDN cache, and all of that can be easily enabled when we have our data available as an event stream. Our reference architecture will consist of 3 pillars. We want CRUD engine to be as close to the data as possible. CRUD engine can be just a microservice in your backend, giving you general data access. For example, product database can be exposed as GraphQL API using CRUD engine. We accept that our GraphQL API will need to be federated, which means that we need to have a way to merge all the different GraphQL APIs into one at the gateway. We also need to integrate parts of our system using events and queues like Apache Kafka. How we can build CRUD engine that's close to the data? It's actually very simple. Instead of CRUD engine acting as a gateway, we put multiple instances of them to interact directly with the database of choice. This scenario supports, typical GraphQL evolution path, where we can start with CRUD engine and, contacting single database for POC. and later build separate microservices for business logic and connect with the existing ecosystem. For example, we can have our Knative serverless containers interacting with the database and exposing specific GraphQL API. We could model our business processes and expose them as a GraphQL API using open source project called Cogito, or even use REST. Since we're going to expose multiple GraphQL APIs, we have a problem of composing them in a gateway. Happy for us, there are multiple solutions out there that will provide this feature. We can use GraphQL Mesh, Apollo Framework, Apollo Federation for comprehensive set of the features, or use GraphQL Proxy like GraphQL Link. We can set up our own gateway or use one of the open source projects. Our federation will also will need to be in a place where we put some authentication. So authentication will be always on the edge, where we don't need to replicate those rules across different CRUD engines and systems. When federating, we can also have a control on what parts of the CRUD engine we want to expose. We want to control elements that are hard to add to the CRUD engines, like concept of resource ownership, field level RBAC, and many more. For example, we can transform generic find method with ability to fetch almost everything to some specific query method we really want to expose. Generic queries are great to get our projects going, but we can easily transform them into specialized one when we go to production. Some frameworks use the compilation part, so you can also compile your queries, but if you have a federation, you can use federation for that. And finally, we want to connect our data, processes, and business logic with the event streams. And event streams are a very generic term that's often overused a lot. So let's see how this is working. If our project use one of the open source databases like Mongo, Postgres, Cassandra, we can use this change data capture that works on top of the Kafka Connect. Not surprisingly, most of the CRUD engines will also use them to fetch data. Kafka Connect allows developers to build ecosystem of connectors that simplifies migrations between different software stacks. With change data capture systems, Kafka events will be published and stored later in database. When you're using change data capture for building GraphQL, we can use the same stream of data to provide data aggregation, GraphQL subscriptions, text search, caching validation, or audit log. Kafka Connects comes with many different connectors developed by community. Debezium is a leading open source solution that works on top of the Kafka Connect API, working with major open source databases. Debezium provides standards for multiple relational and NoSQL databases. Debezium will be providing us raw stream from our database that needs to be filtered and transformed in order to be consumed by clients. Debezium also give us this really simple config and properties, or we can even use dynamic languages like JavaScript to do the filtering. This is really important when we don't want to write and host any Java code. When Debezium is being used, we can selectively pick what changes in the database we are interested in. Like we can filter, transform them into events, and then we kind of consume them later on. When starting connector, we usually specify what tables we want to scan and additional transformations we want to apply. Consumers reads the data from Kafka, giving us ability to react to the changes that were introduced by CRUD engine. We can also revert that, so we can use the Debezium to work with legacy databases and perform data projection into the new database. This way, CRUD engine can work with this completely new, denormalized, reformatted dataset without the baggage of the old backend. The most awesome feature of Debezium, it does a lot of Kafka heavy lifting for us. Debezium will, create the topics representing our database infrastructure, which is valid for the most of the use cases. If we want to have different topic layout, we can always change it in Debezium or have a separate stream processing engine that transform it later. Topics and underlying partitions will be organized, using primary keys, so we can have a guaranteed order. When building solutions for end-to-end users, we often need to fully focus on delivering the value. We don't have a time for experiments or building things for our own. We need to get something proven that works and will integrate with our current infrastructure. That's why there's so many open source communities out there that can help you to succeed. Some elements of the reference architecture that we presented are backed by open source projects that are sponsored by Red Hat. For example, StreamZ will let you run Apache Kafka in production using Kubernetes platform. StreamZ helps you not only to deploy Apache Kafka, but will also assist you with many challenging elements you will have on production, like authentication, data mirroring, and many more. Debezium will provide reliable database event producers that will help you to minimize effort to produce the topics for Apache Kafka from your database. Debezium is fine-tuned for simplicity, removing the need of dealing with specifics, and existing database systems. Finally, Irregular Community provides examples and GraphQL integrations that help you to connect all those projects together with the CRUD engines. Since this talk is just 20 minutes, we haven't got a chance to go deep into the patterns and architecture. You can follow up with me on this and reach out to me using Twitter, GitHub, and work email. Since this talk is delivered remotely, I would love to get your feedback. You can leave your comments at wtrocky.com/feedback. Thank you so much for joining me today. Query your data safely.
And we're back with the guest who's able to speak with us. Wojciech, thank you so much for joining us for a conversation and some Q&A about the presentation that you just gave.
Thank you.
So, this was a really interesting presentation, and you and I had the chance to chat about this a little bit. As someone who talks about GraphQL for a living, I often find myself talking about developer productivity, developer ease, speed of building applications. And sometimes even I forget that there's teams like the security team and the DevOps team and the infrastructure decisions that are made around the deployment of a GraphQL solution matter immensely. And it seemed to me like that's what you were getting at in the presentation, is it's important to design that architecture intentionally rather than just sort of stumble into something. Is that fair?
Yes. So idea is it's simple. Like if you really want to go through the pain of rearranging your entire architecture and backend to add the GraphQL, that may actually put some doubts into GraphQL as a technology. But by the end of the day, GraphQL is just API. So what we want to prove that you can not only have simplicity, and this is what you will get with things like Hasura, but you can also get this by minimally touching your existing infrastructure. So it's not that you eventually not going to end up with your target architecture. It's a step-by-step process. And we know that, in some of the backends, they were built over the years and they're still serving people. We need to be really careful, especially around security, right? What we're doing. So that was one of the alternative architecture that we think that will work in the step-by-step process of adopting GraphQL. In terms of productivity, yes, it's mostly focused on like deployment and satisfying security needs. But obviously, all the CRUD tools giving you this productivity out of the box, so you eventually get the full palette.
Totally, I think the point you make is very well taken for me. In the slides, you gave the example of sort of the generic query and the power of, but also the perception of as a security risk. And it's like, of course, right? Like the app security team might be terrified by that concept even though, it is a common design pattern.
Yes, and I think it's actually very good, like step-by-step approach, because when you're starting this project, you don't need to actually talk with app security first, and when you're deploying it, you may deploy it in a place that is not fully public. This means that you can still have these generic queries, and your client-side team can work with them. Because what I found out when we're working with GraphQL, it kind of gives us this API contract. But at some point, developers, especially on the client side, they don't know what the contract will be. So the contract is being worked on between client and server. And this is a very good feature of the GraphQL. You don't need to think about this stuff up front, spending like 7 days on the meetings to build those RESTful APIs or something. You just drop there some APIs. They're very generic. You can find wherever you want, right? It's like window shopping. And once you get there, you can just transform those queries to something that you're really using currently on your UI at the process when you actually want to go to production. So it's, as you mentioned, it's like productivity is there at the beginning, because if you start with, let's thinking, okay, should I have this and this and within the UI, then it will be actually slowing things down on the UI kind of phase, right?
Yeah, absolutely. It's a very strong reminder that no technology implementation exists in isolation. It turns out that there are teams of people who do things for a living, and designing the solution in advance is powerful. I really like the way you laid out the sort of steps of building your CRUD engine close to your data, federating from day one, connecting the data, the process, the business logic with event streams. If there was one like sort of key takeaway that you wanted everyone who's listening to this talk, either live now or recorded in the future, to take away from it, what's the one big tip that you could give us all?
I think it's like never be afraid to take a shortcut with GraphQL when doing development and apply the CRUD engine, because this is what I see. And then you can always put the CRUD engine in production, even if you have very complex architectures. So CRUD engine can help you not only for developer productivity and getting familiar with the GraphQL, you can push it to your production without changing your APIs.
Gotcha.
And this is quite big, because like in the initial story in the talk, we talked about that, this scenario, two folks adopted the CRUD engine, and then because of that, they decided to rewrite it. But in this history, I actually see sometimes is that decision to rewrite it is often a decision to actually ended up dropping GraphQL, because it's such a big thing to actually start writing those queries, especially have tons of data that you want to pipe. So think about it not only about developer productivity, because obviously you're getting instant boost of those. Think about it as you can still achieve your results. What you only need is just put things in the right place, and that's the outcome.
I think that's gold, and a great reminder for all of us, not only as we begin designing our projects, but as we look at building CRUD engines against existing backends. Wojciech, incredibly helpful. Would you mind sharing your socials again, just so that people are able to reach out if they have further questions?
Yes. So my Twitter, it's Type API.
API.
Yeah.
Excellent. As always, incredible talk, but thank you so much for sharing this information with us.
Thank you very much. See you guys.
And with that, we have reached the end of day one of GraphQL Asia. A few pieces of housekeeping. First of all, thank you. A conference is only as good as the content and the people who are here to hear the content. So thank you for joining us, for making this possible. Of course, got to mention sponsors, because they make this financially feasible. Thank you, Hasura. By now, we've talked a lot about who we are and what we care about. Go to cloud.hasura.io, use the code GraphQL Asia, and you get a month. And tell us what works, what doesn't. Of course, StackHawk, Visit the sponsor booth, win a swag pack. Those are things that matter. That swag pack is up for grabs. And, you know, for a company that has proudly built an application security scanner and can help you manage your security and more, it's worth a conversation. Near and dear to my heart as a data persistence human, Yugabyte. Thank you. If you're looking for a geo-distributed high-performance web scale database, check out Yugabyte. Head to their sponsor room, talk to the team, learn more about what they are up to. And of course, Atlassian. You know them, you've used their product, the team is in the sponsor room, and now you can meet some of the humans who are behind the product, and they're hiring. So with that, we reach the conclusion of day one. Join us tomorrow for day two. We begin at 8 a.m. IST. Adrian will be back to MC. I'll be joining partway through the day. Of course, we're available on Twitter. The hashtag is GraphQL Asia 2021, and we look forward to connecting again tomorrow. Thank you.
Things are getting complicated. Nothing's gonna stop this shit from sinking down. Think we need some mediation. I get it all for you. Why the hell do I fall for you? Baby, 12 a.m. you're dodging all my phone calls, baby. Why ask me? You already know it all, baby. Don't you play around with me tonight? If we go in, don't do it tonight.